This conference will now be recorded.
So good morning, one and all. These are the topics we have discussed so far in the first unit related. That is introduction, basics of digital importance of hexadecimal number system, definition of processor, different blocks in microprocessor from computer architecture, applications of processor and microprocessor microcontrollers, features of processor, evaluation of processors, functional diagram of processor, 8086 architectural block diagram, and today's topic is register organization of 8086 microprocessor, right? And this is the functional diagram of any processor. A functional diagram means what are the different blocks and what is the functionality of each block is called as functional diagram of processor. Right. This is the 4004 microprocessor. We know that any processor will have three sets. One is register set, second one is ALU unit, and third one is control unit. These are the mainly three blocks inside of the microprocessor. This is called as the microprocessor, right? And different blocks here we are seeing different blocks, but different blocks are categorized into three parts only. One is register set, second one is ALU, and third one is control unit. Right, and this is the 8085 microprocessor. This microprocessor is also having three sets: register set, ALU unit, and control unit. Right. So this is my 8085 microprocessor also constructed using three sets. One is register set, ALU unit, and control unit. These are the features. This was explained in the previous first class. What are the features of 8086? But here today's topic is depending upon this one. That is, it is a 16-bit microprocessor. What is meant by 16-bit microprocessor? I told you it has 16 data lines. It has 16-bit ALU. It has 16-bit registers. Right. These are the 3 points we have to remember. What is meant by different processors? Right, 16-bit processor, 64-bit processor means it must have 16 data lines, 16-bit ALU to perform 16-bit operations, 16-bit registers. So 8086 is having total 14 registers it is having internally. Right, that is the today's topic. Right, so register array of 8086. You see, any processor must have three units: ALU unit, control unit, and register set. You see here, control unit, arithmetic and logical unit, and register set. Okay, ALU stands for arithmetic and logical unit. When you come to 8086, before going to that, here register and memory are storage elements. You remember, both registers and memory are storage elements. Right. Register stores few bits of data, whereas memory stores huge or bulky amount of data in terms of megabits, gigabits, terabits, and so on. But in the case of register, they are storing only 4 bits, 8 bits, 16 bits maximum. We are having 64 bit of registers only. Whereas in fourth unit, we will study 32-bit registers. But in the case of first unit, 16-bit registers. In the case of second unit, 8-bit and 16-bit registers. Whereas memory stores huge or bulky amount of data in terms of megabits, gigabits, and terabytes. Right. So registers are inside of the processor, whereas memory is outside of the processor. Right. Registers are inside of the processor and memory is outside of the processor. So these are the differences between, right, register and memory. Registers and memory both are storage elements. But register stores few bits of data, whereas memory stores huge or bulky amount of data. Registers are inside of the processor and memory is outside of the processor. And here we have to remember, right, when we are fetching data from the memory, these data or instructions are stored in the processor registers. This is the main point here. Why we need to study this topic is when we fetch the data either from memory or from IO, those instructions or the data must be stored somewhere inside of the processor. That point or that place is called as register set, because registers and memory both are storage elements, whereas memory is outside of the processor, whereas registers are inside of the processor. So inside of the processor also we need a device which can store the data, right? So you see here, but register is a temporary storage element. Okay, registers are temporary storage element. Whenever memory is outside of the processor, we are accessing the data through the registers. So the registers are inside of the processor. So the processor accesses register more quickly than memory, because the memory is outside there, so it takes time to access, whereas registers are inside, so it takes less time. Right, so that's why for faster access, we are taking these registers inside of the processor. Right, but how to design these registers, right? So flip-flap in the second year I have studied digital system design subject. So flip-flap or a latch is a 1-bit cell or 1-bit storage cell, 1-bit memory cell, which can be used for storing the digital data, right? Flip-flap is a 1-bit memory cell or storage cell, which can be used for storing the digital data to increase the storage capacity in terms of number of bits, because one flip-flap can store only 1 bit. Suppose if I want to store, I just now I told you, right? We are having today, we are having up to maximum 64 bit of registers, right? Or 32 bit of registers. So to store this 32 bit of registers, we need to take 32 flip-flaps. It means the n-bit register will consist of n number of flip-flaps, right? So that is the capability of the register. The n-bit register means 16-bit register needs 16 flip-flaps. Understood? Right. So this is the story about this one. The main intention of registers here inside of microprocessor is they can shift the data, they can move the data, or they can copy the data from one location to another location, one register to another register. Is known as the register. Right. This is the introduction about the registers. Right. Now the register array processes the data via the number of registers that acts as temporary fast access memory locations. The flow of instructions and data through the system is managed by the control unit. Right. See here, for example, if I want to store 4 bits, that is called nibble. If I store 8 bits, is called as 1 byte or 2 nibbles. If I store 16 bits, right, that is known as the 4 nibbles or 2 bytes of data. Right. So this is the way of representing the data. Right now, suppose if you have 2 bytes, how to represent 2 bytes? The 2 bytes, one is called as lower byte and second one is called as higher byte. So byte means 8 values or 8 bits. See here, 1 to 8 is lower byte, and 9 to 16 are called as higher byte, because these are the higher values compared to these values. This is the edge rate status. So here these are the different blocks of 8086, that is bus interfacing unit and execution unit. And here some of the registers are available in BIU and some of the registers are available in execution unit. Right. So what are the registers available in bus interfacing unit? Segment registers and instruction pointer. What are the registers are available in execution unit? AX, BX, CX, DX, SP, BP, SI, DI, and flag register. So these are the different registers available in architecture of 8086. The architecture of 8086 is called as bus interfacing unit and execution unit. So the different blocks of 8086, bus interfacing unit is having segment registers and instruction pointer, whereas execution unit is having all these registers. So this is our topic today. You see here, right, this is called as bus interfacing unit and these are the registers, and this is called as execution unit and these are the registers. Right, so I'll show you one by one. And this is the program. Here you can see that AX, DS, AX, BX, AX, AX, and these are all called as registers here. To write the program, we need registers, right? As you explain one by one. And these registers, In 8086, we're having 14 registers, and these registers are grouped into 5 types. They are general purpose registers, index registers, segment registers, point registers, and status register. General purpose registers are AX, BX, CX, DX. Index registers are source index and destination index. Segment registers are CS, CSS, CS, DS, and IP. IP is called instruction pointer. It is related with CS, that's why I'm giving here, but it is actually not called as instruction pointer, is not called as segment register. Only these four are called as segment registers. Right here, S stands for the last, S stands for segment, C stands for code, S stands for stack, E stands for extra, and D stands for data. Point registers SP and BP, and status register, which is also called as flag register. And these are the different registers available in 8086 microprocessor. Right. So first one is general purpose registers. So they are available in 16-bit or 8-bit. Okay. So here you see that general purpose registers are, if they are available 16-bit, must they have to write AX, BX, CX, and DX. 8-bit, if we take it as 8-bit, then we have to write AH comma AL, BH comma BL, CH comma CL, and DH comma DL. Right, AH, AL are part of AX. BHBL are part of BX, CHCL are part of CX, and DHDL are part of DX. Then here what is AX is nothing but X is nothing but extendable. What is meant by extendable? Whereas 8085 is an 8-bit processor, whereas 8086 is a 16-bit processor. So 8-bit నుంచి 16-bit కి మనం extend అయ్యాం కాబట్టి 8085 లో accumulator register has shown as A. In the case of 16-bit, this A has been taken as AX, means extended from 8-bit to 16-bit. Again, this AX can be written as AH and AL. H stands for higher byte and L stands for lower byte of AX, BX, CX, and DX, and these are part of execution unit. Right? General purpose registers are part of execution unit. Right. So general purpose registers are used for temporary storage of data and memory access. This is the main point of this general purpose registers. So 8086 has 4 general purpose registers: AX, BX, CX, and DX, and these are available to the program for storing values during programs. Right. So each of these can be divided into 2 8-bit registers, such as AX as AHAL, BX as BHBL, CX as CHCL, and DX as DHDL. In the case of AX, right, AH is called as higher byte and AL is called as lower byte. Right. In the case of BX, BH BL, BH is lower byte and BL is lower byte, and BH is higher byte. CH is higher byte of CX and CL is lower byte. DH is higher byte of DX and DL is lower byte. Right. And beside their general use, these registers also have specific functions. Right. What is the function? We will see one by one. AX is called as accumulator register. It's a part of execution unit. Right. So you see here where AX is available. So this is the execution unit, and here AX is available. Right, this AX is having 0 to 15. 0 to 15 means 16 values, and the 16 values can be written as AL and AH as 8-bit, 8-bit, or completely 16-bit if you take it as AX. Right. So AX is an accumulator register. It is used for arithmetic and logical data functions. Right. What is the meaning of this? So U is having arithmetic and logical in it. So to perform arithmetic and logical in it, we need data, and that data temporarily stores in general purpose registers. Okay. So that is the meaning of this AX register main purpose. It is a set, and here AX and AL is called as lower byte and higher byte. Now here, right, so first you see what is instruction. Instruction is having 2 fields, opcode and operands. Now what is a opcode? And operands are 2 types: destination operand and source operand. Opcode means operational code or instruction. Operands means used to hold or represent data or address. Right, suppose move AX comma 1 2 3 4 H. move bx comma 1221h, add ax comma bx. Right, you see here I am taking 1234h is a 16-bit data. How can I say 16-bit data? Because it is H stands for hexadecimal. Hexadecimal means each value is in terms of 4 bits, so 4 into 4 is 16 bits. So the 16-bit data can be moved into AX register, and this 16-bit data can be moved into BX register. Now here I am adding add AX comma BX means I am adding AX and BX, but where result will be stored after adding the data, again it will be stored in the destination. Destination means that is the meaning of destination, our ending point. So after adding the data, before adding the data, it's called destination operand and source operand. And after adding the data, X is called as a register to store the data. Right. So this is the little bit about to understand this AX register. So this AX register is also used to store destination operand before the operation, and after the operation it stores the result. It also holds operands and results during multiplication and division operations. Right, and it is also used for IO operations, and it functions as accumulator during string operations. So it is used for string operations, it is used for IO operations, and it is used for source. Used to store destination operand, and after the operation it stores the result also. Right, this is the AX register, this is BX register. So BX register is also part of a execution unit, and this is all 16-bit register, and its main motivation is to hold memory address, and it is used to hold as a source operand or destination operand. Right, and these are some of the examples, and it's also used for multiplication and division. Right, advantage and disadvantages of hexadecimal is here multiplication and division operations are a little bit difficult. So that's why here we are having different formats of multiplication. Mul BL and mul BX means only one operand is there. But in the case of 8086 previous, if you see here I have taken two operands. But in the case of multiplication we are having only one operand. But result will be stored by two registers, AX and DX register. If you multiply AX with BX, result will be stored by AX and DX register. And CX is a counter register. What is meant by counter register? Right, whenever you want to perform counting values or to hold count values for instructions like loop instructions, rotate instructions, shift instructions, string operations, then we use CX register. Here you see move CX comma 0005. Back move AL comma BL, add AL comma BL, move BL comma AL, loop here. Right, if you don't understand the problem, no problem, but here you see that this program helps us to understand, right, what is the functionality of the CX register. CX register stands for counter register. So it means here it counts the 5 values, because move CX comma 0005 means 5 values are moved into CX register, and this loop will be repeated for 5 times. Right, for and the operation of loop is to check what is the value of CX. When one operation is performed, again this loop will check what is the value of CX. Now it is 4. Again this loop will be continued. Again this loop will check whether CX is what is the value. Right, 4 become 3. Like that CX value will be automatically decremented by 1, and when it reaches the 0, it will come out of the loop. Right, but here to store 5 values, to perform 5 times 5 values of addition, then we need to have the CX register. DX is called as data register. Right, block diagram of 8086 is having this one, and here it is called as DX register, which is also called data register. Its main motto is to perform the string operations and for the multiplication and division operations. Here you see that mul bx means here ax is multiplied by bx, and result will be stored by dx and ax, because if you multiply 16 bit with 16 bit, then the result will be 32 bit, but ax capacity is only 16 bit, then the remaining 16 bits will be stored by dx register. Suppose if you take division, I'll get remainder and coefficient as a result. Remainder is stored by dx and coefficient is stored by ax register. Right, see here input values are ax, bx, and output values stored by dx and ax register. Right, segment registers. Right, so here segment registers are part of bus interfacing unit, and here we are having 4 types of segment registers: extra segment, code segment, stack segment, and data segment. These are the 4 segment registers here. Right, you see here, before going to that, here what is meant by segment we will see. Right, here we have 4 segments. Data segment used for keeping the data values, and code segment is nothing but, in the normal programming, code is also called as a program. Right, set of instructions is called as program, a group of instructions is called as program. Technically it is called as code, and this code segment helps us to store the program values as a program instructions, and data segment is used to store the data values. Like that, different purposes they have taken these 4 segments. And before going to that, here we need to explain this a little bit. So 8086 has 20 address lines. What is the need of 20 address lines? Right, 20 address lines means number of address lines only gives the what is the capacity of the memory. Right, any processor memory will be decided by only number of address lines. A mobile phone is also having, right, 4 GB, 5 GB of memory, 32 GB of memory, means that is depending upon inside a processor it has, and it has the number of address lines, and that number of address lines only will give the what is the total memory capacity of that processor. Right, so here, but 8086 memory is 20 bits, but registers are in terms of 16 bits. Then there is address conversion mechanism to convert 20 bits to 16 bits to 20 bits, that we will see later. But here, what is the physical address location of the memory? How they can calculate? So the physical address of memory is calculated by segment address plus offset address. Right, there is a separate topic on this that we will see later. Now here, what is the segment and what is the offset? You see here in the textbook, each chapter is called as a segment, each subtopic is called as a offset. In the book, we will have 4 to 5 chapters, and each chapter will have subunits internally. We will go to that subunits only to read particular topic. Right, so here complete address of that particular topic will be decided by this particular topic is within the say of so and so topic, and that so and so topic in the so and so subtopic. So here chapters are called as the segments. See here segments, and pages are called as the offsets. That is what we call the complete physical address. Okay, so here now how to calculate the physical address or the so and so segmentations are. So 1 KB is equal to 1024 bytes. Now I am ignoring the word called byte, and I am calculating the remaining. Right, so 64 KB is equal to, shall I write 64 into 1 KB? We can write. So it is equal to 64 into 1024 is equal to 65,536. If you multiply, then it gets 65,536. So that can be represented as 0 to 65,535. Right, now 1 MB is equal to 1024 KB. Right, because 1000 times of 1000 kilo is equal to 1 mega. Right, so 1024 KB, which is equivalent of 2 power 20. Right, so 1024 KB also can be written as 1024 into 1024, 10,48,576. It also can be written as, if you multiply 16 with 65,536, you will get 10,48,576. So it means 2 power 20 also can be written as 16 into 64 KB is equal to 1 MB. It means 1 MB is also can be represented as 2 power 20 or 16 into 64 KB. Like that we can write. So 2 power 20 is equal to 1 MB. 64 into 64 KB also can be called as 1 MB. So the total 1 MB of data has been divided into 16 logical blocks. Each block is equal to 64 KB. So 16 into 64 KB is equal to 1 MB. So these 16 logical blocks are called as segments. Out of these 4 logical blocks, 4 segments are used for different purpose. Right, only 4 of these 16 logical blocks are called as 4 segments in 8086. What is a segment? A segment is a logical unit of memory. Segmentation is the process in which the main memory of the computer is logically divided into different segments, and each segment has its own base address. It is basically used to enhance the speed of execution of the computer system so that the processor is able to fetch and execute the data from the memory easily and fast. Easily and fast, that is the main motto. Right. So here there are four types of segment registers: code segment, data segment, extra segment, and stack segment. So code segment is used to hold the program, data segment is used to hold the user data, and the extra segment is also called as extra data segment, and it is used for string operations mainly. The stack segment is used for temporary storage of data. I'll show you. Next one, instruction pointer. Right. So if you see this segment is, if the segment is code segment, then offset is stored by instruction pointer. So that's why here it is also called as program counter, which gives the address of next instruction along with the code segment to execute the physical address. Right, it is used with the code segment to calculate the physical address, but main purpose of instruction pointer is used to calculate the address of the next instruction. See here, physical address of code segment is called value of CS into 10H plus value of IP. So what are the advantages of segmentation? So program and data can be represented separately. It has powerful memory management mechanism. It allows to extend the addressability of the processor. Like that, we are having so many advantages using segmentation. Register organization: point registers. SP and BP, stack pointer and base pointer, are part of execution unit. You see here, right? SP and BP are part of execution unit, right? What are this? They are related to, point registers are related to with stack. Right? The stack is a block of memory that may be used for temporarily storing the contents of the registers inside the CPU. Right? See here, what is meant by temporary storage? Right, this is the media player. Here I am taking here 5 to 6 songs or 6 to 7 songs we are storing in this place. How one by one the songs can be play one by one? Suppose now we are drawing the one by one songs and we are keeping here, right? And you can relax, the songs will be played one by one. But after playing the first song, how it will be point to the second song? That is known as the stack pointer and base pointer. Stack pointer means if you collect the data, if you are executing data within one segment, is called a stack pointer. If you are taking the data with different segments, and if you write the one program, then the different segments, they are pointed out by base pointer. That is the stack pointer and base pointer. Index registers are part of execution unit. Right. What is the main motto of index registers here? Index registers are used to calculate offset address of the data segment mainly. Right. You see here, right? Physical address of memory is equal segment address plus offset address, and index registers are used to calculate, right, offset address along with data segment and extra segment that you can notice here. Data segment is having bx comma di comma si, and extra segment is bx comma di comma si. Here these are the segment registers. Okay, and the status register. So what is status register? Status register is also called flag register. Whenever you are performing some operations, then it may generate carry, borrow, overflow, sign bit, negative values, like that. How it will be identified? By using the status or flag register. And this flag, what is a flag? The flag register contents indicates the result of computation in the ALU to control the CPU operations. This is called as flag register. So that we will see in the next presentation. Any questions, please ask me. Right. Thank you.